let me thank you for coming. I know it's late in the day. It's been a long day yesterday, and then those of you who were here, it's been a long day today, and those of you who were here yesterday. So thank you for coming. So in this panel, we're going to talk about AI and the data provenance dilemma. Now, the title of the panel actually came from a research paper that two of our panelists, Robert Mahari and Shayne Longpre, published sometime last year on the data provenance dilemma, which they will explain. But then when we had a call and we discussed the panel, we decided to expand the whole question of the data provenance dilemma to the question, where will all the data needed for AI come from? So let me start by asking each of the panelists to introduce yourself, tell us your affiliations, and then we'll start with some questions. And this is a very freewheeling panel, so feel free to ask questions anytime, let's have a very freewheeling question. So go ahead, Robert.
Perfect. Hi, everyone. My name is Robert Mahari. I'm doing a JD PhD, so I'm at Harvard Law School doing a JD. I've kind of wrapped that up, and at the MIT Media Lab, which is MIT's kind of interdisciplinary department, doing a PhD. And my focus is kind of on two things. One, leveraging AI to extend the abilities of lawyers. For this kind of group, helping in-house counsel be more effective by using technology. And then second, thinking about AI regulation and how we actually take that and embed it into technical specifications to help with compliance and risk management. So happy to be here.
I'm Shayne. I am only half of Robert. I'm doing just the PhD at MIT. And my focus has been on training AI models, foundation models, or general purpose language models like ChatGPT, and also understanding the data that goes into that and how to curate that data in a way that won't get you into ethical trouble.
Okay, and I'm Mike Mason. I'm the Chief AI Officer of a company called Thoughtworks. We're a technology consulting firm. We've got about 10,000 people globally, and we build a lot of custom software for our clients, help them navigate how to bring new technologies into their company and how to solve their problems with that. And of course, under that banner, everybody's interested in AI these days. So we're having a lot of conversations with clients about how to leverage AI for their business outcomes.
Very good. So we'll get to the legal questions that sort of got us going. But before that, let's briefly discuss a topic that has come up several times in different talks before, which is that one of the key characteristics of AI, in my opinion, it may be the key characteristic, is the central role played by data. And the way I think about it sometimes is that, let's say computers sort of started, let me say, in the 1960s, sort of to be going into the commercial world. And since then, we were in this sort of software-centric era of computer, where the center of computer was software, system architecture, and of course, the technology that ran all that. But then, started in the 2000s, data took off because of the internet. All of a sudden, we had all this digital data, and then software continues, but all of a sudden, we started in the data-centric part of the world of IT. And in my mind, that's the key to AI. And let me ask each of you to comment if that's a good way of thinking about AI. Robert?
Yeah, I think the role of data is different with generative AI. And the key thing is that, 5 10 years ago, if you wanted to use AI, you needed to find a bunch of data and train your model. And now someone has done that heavy lifting for you, and you can just ask the models to do a thing and they'll do it, right? This kind of whole idea of zero-shot learning. And so I think this has been really impressive. At the same time, and we can get more into it, I'm just trying to be quick, there's still a place for your own data sets, and this idea of retrieval augmented generation, where you kind of customize what the AI is doing using proprietary data sets, is really quite powerful. So it's different, the role of data is different, but a lot of the kind of learnings from old school AI still definitely apply.
Yeah, but remember, when you say old school AI, I think you mean machine learning and deep learning, correct?
Yeah.
No, this is a very interesting thing, because the old school is, I don't know, 10 to 15 years old. So what's interesting, and we'll talk a lot more, is, and this came up in a previous panel, we're being too dismissive of this quote unquote old school that we use to train an AI machine to play championship level Go. I mean, that was not a simple thing to do. So the old school is not so old school, so we should talk about that. Shayne?
Yeah, I think the key distinction from old school and now is maybe the scale of compute and data that we've thrown at things. So I'm an academic researcher, and so much of the academic work that's been done over the last few years, many of it's very important, much of it is, but a lot of it has just been ruled out as not relevant, I'm gonna say, because simply just making a bigger model, with using more data, leads to better results. You don't need anything else. It's sort of a bitter lesson. But the problem, maybe to introduce the problem this panel might talk about a bit, is in order to build models that are very general purpose, can do many things that are more powerful, more data is better. And so a lot of companies will try to find as much data that's publicly available on the web, scrape that. But the issue is that the web is fundamentally unstructured. And so it's not labeled well. We don't know what subsets of it are permissible, legally or otherwise, are ethical, or even relevant to the thing that maybe you want to train a model for. And so that's the challenge that we're currently facing, and that people have all this data and we don't know which subsets we shouldn't use, or how we should use it necessarily. We just train on all of it and pray for the best. And maybe we need to solve that in the next few years.
Shayne, as you're talking, I was remembering that when I first started reading about foundational models, and I think it sort of started out of Stanford. They wrote a great paper on foundational models and so on. They said one of the reasons they wanted foundational models is because it was a pain that in the old stuff of deep learning, every model had to be trained with data for its application. And if you wanted something for a different application, you had to go through and train that for that application. And so what they found so appealing about foundational models, and I'm making a distinction between foundational models and LLMs and generative AI, which we can discuss, I don't know if there is a distinction, is there is so much data there that, you know, one day you can ask it questions about poetry, and the next day you can say, what do you think of the Yankees versus the Red Sox? And it's all there, so you don't have to keep training the model. Is that a correct way to think about why Gen AI became, or foundational models became so popular, that they can do many things without additional training?
I think that's why people are really excited about it, but a lot of the applications that many of you might use it for might only depend on a very narrow subset of those use cases.
Yeah, and so I think a couple of things that are interesting. So the big data revolution, maybe 10, 15 years ago, was the start of organizations feeling that they needed to save every scrap of data that they could possibly get. And that's actually turning out to be a useful input to some of today's AI models.
And Mike, when that started with big data, were they saving mostly structured data or also unstructured data?
So it was a combination, but certainly a lot of structured data, click streams, digital exhaust as people move around the internet.
So they started to get saved.
Yeah, and so people were told, data is the new oil.
Yes,
you
yes,
need to
yes.
get as much of it as
Right.
you possibly can. And some of that is turning out to be useful for today's AI models. But I think the thing to recognize also is that existing machine learning technology is pretty advanced. So there are instances where that stuff is so highly tuned that you can't actually match it with generative AI that has this general tuning model. So we did some work for a fashion retailer, an apparel retailer, doing some kind of article recommendations.
Yeah.
You're browsing their catalog. And their existing system was just so well done with so many years worth of data and so highly tuned as an algorithm that the new stuff with Gen AI actually performed worse, and you could measure that. So I think that's another thing that's happening with Gen AI. It, as people have said, it has taken up all of the oxygen in the room, and people only want to talk about Gen AI, when in actual fact, there are multiple things that you can do with data here today, and one of those might be Gen AI.
And Mike, you brought up a very interesting question. You said this system was so highly tuned that it did a great job. Is that a good thing or a bad thing?
Well, I mean, if you're a retailer trying to sell stuff to people, presumably you want to sell as much stuff as possible, and so therefore...
No, because that's a great question that we should be discussing, because it is the difference between a highly tuned model for the domain you want to apply it to and something that's very general but may not perform as well. And let me ask you a question on that. And again, we are all over the place because this is such a thing that's all over the place. We know that Gen AI suffers from hallucinations that at one point in the conference I said, I think I would call that a data bug. That is, if a software system crashes, you don't say, gee, the software system had a hallucination. You say the software system had a bug and crashed. And somehow if the AI, as happened with some lawyer, gives you an article that didn't exist, people call that a hallucination. That felt like a bug to me. And so I'm assuming that the more tuned models don't have hallucinations in the same way, and that's partly why they may perform better, but only in that domain. Is that correct?
Well, so I think hallucinations are a problem, and generally I would talk about reliability of large language models and the ability to ensure that their outputs are good. And this is kind of an area of active research. I think every one of the major AI companies.
But that's a very good point. So you're saying beyond the legal things that we'll get to, there's also the active research area of, depending on what you're trying to accomplish, you may be better off with a highly tuned domain model than with a very general model. That's what you're saying.
Potentially, yes. I think there's this spectrum of Gen AI usage that starts with something pretty simple, which is just using an off-the-shelf model from one of the big AI companies or an open source model, and just doing some prompt engineering on it, asking it good questions, and maybe building a lightweight task-specific UI on top to give people some workflow as they're using it, rather than just kind of raw prompting. And you can kind of go up from there in terms of complexity. Robert mentioned RAG, Retrieval Augmented Generation, which allows you to do a kind of a step up in terms of anchoring the model, making it sure it's being a bit more factual. And then you can go even further than that and fine-tune a model on your own data. As you go up this spectrum, you're spending more money, you need more technical expertise, it requires more data, more time, and then you get into the sort of the very high end where you might potentially be building a model from scratch. And so that's the most expensive thing that you can possibly do. And I think the path here is that organizations are going to be working their way up this stack, learning more about it and learning what do they actually need to do to get a good outcome from a particular model.
Yeah, no, that's very interesting. There's another interesting question I want to ask you. Both Shayne and Robert are part of a group in the Media Lab called Connection Science. I know it has sometimes different names. And it's led by Professor Sandy Pentland. And I'm a fellow of Connection Science in MIT. And several years ago, Sandy wrote a book called Social Physics. And you know about the book, obviously, right?
Less so than Robert.
Okay. But Sandy's main point, and the reason he called it social physics, is if you go to a physicist, and by the way, my PhD was in physics, and you say, do you know that large data is very important to do work in physics? They would say, why are you telling me that? Because if you go to CERN in Switzerland, Robert is Swiss, high energy physics is all about analyzing huge amounts of data to find the Higgs boson. And if you go to astronomy and you say, gee, I want to look for extragalactic planets, that's all a massive data analysis problem and so on. What Sandy wrote about, and what I think is a lot of the research of your groups, is that for the first time, we have enough data about the behavior of people as individuals and in groups that we can apply data analysis, very sophisticated data analysis, to understand the behavior of people and groups. Is that correct?
Yeah, I mean, so Sandy, I think, essentially created this field of computational social science.
Right.
I think
and that's very new, correct?
I mean, new in the kind of grander scheme of things.
In the grander scheme of, yeah.
But I think what's kind of funny is we've come full circle, where what Shayne and I have been doing is almost the social science of computation. We are tracking down these data sets and trying to figure out who made them, why did they make them, under what conditions did they make them, are they reliable or biased or toxic? So it's funny how there's kind of this circularity to it. But understanding AI as kind of a social process that has a supply chain and that has different actors with different incentives, I think could be helpful, certainly for academics, but also I think in certain business contexts to understand what you should and shouldn't be using under what circumstances, and how you can kind of proceed in a way that gives you access to the potential of AI without accidentally violating regulations or otherwise exposing yourself to risk.
Yeah, and something that I have found very useful when I started to think about all this, and this may sound a little chauvinistic coming from the sciences, is that everybody agrees that if you're doing research, you want to apply the scientific method, and the scientific method is all about empirical experiments. You do that, you gather a lot of data, then you analyze the data, and then you see what's going on, and then you try to develop a model to explain it, whatever. And we've applied the scientific method to physics, biology, the usual things. And yes, we've analyzed data in the social sciences, but not to the extent that Sandy meant. And even in the humanities, you can now apply it to analyze, did Shakespeare write his plays or was it somebody else? And humanities people, so this expansion of applying the empirical scientific method has been huge for all kinds of fields. Is that correct way to look at it, especially as you look at the research going on?
Yeah, I'd say so. It seems like general purpose models can be applied to just about anything. They can also be misused in so many different ways. So people have a lot of confidence in it, and they can also over-rely on the outputs that it can produce, especially when it's generative. It's written to be compelling. It's actually trained and reinforced to follow the preferences of humans. So if you scan this text, and you see the bullet points and the word delve and other features in it, you're convinced psychologically that this is a phenomenal response. It might hallucinate articles. It might actually not be the correct or intelligent interpretation of things. So I think there is going to be a time where we're using it for scientific purposes, but the literacy of how to use it appropriately and at scale is lagging. And that's something that may have to catch up.
Yeah. Now, Mike, you are the Chief AI Officer at Thoughtworks, and you deal with customers from all over the world. I think we were talking yesterday. You had just recently been in India. And how is the ability to treat many aspects of a business using this empirical scientific method of analysis transforming the way businesses work, whether it's in marketing, in sales, in customer service, or whatever, based on how you're working with customers?
So I think I'm going to say something that might be unpopular amongst my colleagues, but lots of organizations, there is so much fuzziness in the data, that it's actually, I think, difficult to really use the scientific method to prove something about a business, because there's so many gray areas and fuzziness about what's going on. One of your colleagues challenged the table yesterday, said, everybody realizes that data is an asset, right? And everybody puts their hand up, and he says, okay, so what's your return on data is the challenge. What's your risk-adjusted return on data? Even more difficult. And I think most organizations actually have trouble measuring the return and actually measuring the investment, because the average company has so many moving pieces that there's this fuzziness. So you always have to build a compelling narrative for why the results that you're seeing are worthwhile. For some particular use cases, you get very concrete metrics. We're resolving customer service queries faster. We're handling more requests. We're more accurate. All that kind of stuff. So in some of those cases, you can get very specific answers. But especially when it comes to things like using AI as a productivity tool, measuring people's productivity in the first place is actually quite difficult to do. So we work in the software field, and early on and still now, there's a whole bunch of noise around AI that can create code. So maybe we don't need programmers anymore, or everybody can go 50% faster, or whatever the headline numbers are. And I think the problem is, unless you have a group of people who are solving the same problem over and over again, the problems that you're coming at you are so different that it's very difficult to measure, did we do a better job this time than last time because we have some new tool? And so there's a lot of subjectivity to it.
No, I understand. As you were talking, what I was thinking is, let's take finding extragalactic planets. No. A lot of the innovation was the physicists or astronomers figuring out a way of finding the planets. In other words, they had to figure out, well, we are measuring, looking at the stars, there's a little bit of light that changes. So they devised an experiment. And that took a long time. So what I'm wondering is the applications in business to get around the fuzziness. I'm assuming they will get better over time as people in business schools like Sloan and people like Shayne and Robert, and so people like you get more and more. In other words, part of the thing is that this is so new. We are learning how to do it. And we have a lot to learn how to apply it in what you said is sort of fuzzy business things. Is that do you agree with that?
Yeah, I do. And I think something that's happening in all kinds of organizations is we are figuring out how can we do things more incrementally, because the results are they're difficult to predict.
Yes.
Like these are, businesses are complex systems, and so you can't just predict what the outcome is going to be. So the question is, how can we, both through the way we organize our company, the way we organize our technology, do something small and then measure whether we got to moved a step in the right direction.
So take a sort of agile approach.
Certainly iterative, yes.
Iterative, agile experiment, but that's fairly new, right? That's all.
Well, I don't think it's new because we've been doing it for 30 years, but like lots of organizations still get stuck in the trap of saying, oh, we need to do a multi-year project before we
So let's get, before going to questions, on what motivated the title of the panel, which is you two guys finding out that the data that was used to train generative AI models was illegally obtained, and they just did it. Whoever did it just did it. So
maybe I can give some headlines, then the lawyer can talk about the illegal part. The headline things that we found in this work, and others have corroborated in various places. If you're trying to build a general purpose language model or AI tool, this might be separate from what many of you are trying to build in your companies, but it might be something that you personally or others might want to leverage, including in companies, is that a lot of them source not just from the web, but they source a lot of their data sets, specific data sets from large repositories. One is called Hugging Face, the most popular one. And in that repository, we found that 60% of licenses were either omitted or incorrect. And this is because it's ultimately a crowdsourced tool. And so people were using data under the wrong assumptions about the original intention of the use, regardless of whether that's enforceable. We can get into that in a minute. But beyond just the legality of it, I think there are many reasons that people care about the data, especially if you want to supplement from external data outside of your company or external models outside of your company that might be trained on external data. And that is the copyright problem. So in December, it was a big month for AI. The New York Times launched their lawsuit against OpenAI and Microsoft. Two other things happened that flew under the radar. The other one was that the Lion 5B, which was the most popular large text-to-image generation data set, 5 billion images scraped from the web, it had to be taken down because they found that hundreds of images of the 5 billion contained extremely inappropriate, sensitive, pornographic, illegal material. This is another element of provenance that's very difficult for people when they're using large data to figure out what does and doesn't have appropriate material. And the last one was that many companies are now increasingly using synthetic data created by models. And the most popular models to use are OpenAI or Anthropic models. But OpenAI actually suspended the account of ByteDance, the creator of TikTok, for using their OpenAI accounts to generate synthetic data to train their own models.
That we call that in New York chutzpah, in the sense that OpenAI stole data from other people, and now they are upset that TikTok got their data.
Listen, there are many problems. Everyone's very confused. Now Robert's going to tell us the
No,
way forward.
but that takes, it's like, it's okay for us to steal, but it's not okay.
There's perceived hypocrisy, for sure.
That was what I meant. There is perceived hypocrisy. That's an excellent term. See, he's Canadian, so he used a very polite term, perceived hypocrisy. Wow.
Just like as a bit of background, because we're talking about this data provenance initiative as if everybody knew. So it's this research project that we launched about a year ago to kind of chase down all these data sets. And I will note, it's grown significantly. So in the first one, I think we had something, like 15 to 20 co-authors. That was the version 1 we published in September. The last kind of all-hands call we had was 70 invites.
Oh, wow.
Essentially, we are trying to annotate the internet and all the training data.
And that's not all MIT people.
No.
From all over the place.
Dozens of collaborators all over
the world. Are they all well, you're not a lawyer, so they're lawyers, computer scientists, everything.
Yeah. And then if you start counting the data annotators that we've hired, it's a much larger number too. So essentially, it's been this kind of collaborative effort between lawyers and computer scientists to annotate all AI training data. And on the legal side, so we started with fine-tuning data sets. So these are data sets that are interesting from the legal perspective because they're created for one purpose and one purpose only, which is to train AI models. And so a lot of the AI training happens under the guise of fair use. Well, you didn't write this poem to train AI, so we're using it in that way. And that really doesn't jeopardize the market for the poem or whether people will buy it or enjoy it or things like that. That can't be said for a data set that was created for one purpose, which is to train AI models, right? And then you're using it in that way. So we went out and we looked at kind of what are the licenses that people are applying to these fine-tuning data sets. And we saw a big jump. Up to 2022, 20% of them were licensed permissively, including commercial use. 2023 comes along, we see a jump to about 60% of them being licensed only for non-commercial use. Probably people waking up to the fact that, hey, there's like real value here. And so then we wrote a lengthy kind of comment to the US Copyright Office explaining this distinction, right? That fair use is unlikely to apply in this instance. And that there are real good policy reasons to enforce these licenses because the creators are actually in a very good place to assess what the data should be used for. And we also probably want to create continued incentives to publish this data openly because having transparency about the data, I think we both deeply believe that, allows you to assess the vulnerabilities that adding that data is likely to introduce to the model.
Robert, you may want to explain fair use.
Yeah, so fair use, for those who don't know, is kind of this American principle of copyright law that you can use things that are copyrighted without obtaining permission for certain in certain contexts.
So let me ask you a question. So let's assume I like Taylor Swift, and I want to use her songs, her words, whatever, to do things, to generate new songs and new lyrics. Would that be fair use?
That's like the mother of all hypos. No, I mean I think there's no clear-cut answer. Depends how much you do.
So that would have to be litigated.
Our lawyers are too good.
Yeah, but look, if you use Taylor Swift songs to teach a class,
that's fair use.
Yeah, that's fair use. That's like an easier example. And you said, contemporary music.
I understand. But if I use her songs to create a new song that I want to make money from,
that's probably
I could get sued. That gets a little bit into.
That's probably infringing.
New York Times suing.
Yeah, exactly.
No, but this is fascinating. Yeah, so let's turn. Do you have any comment on the legal things, or shall we turn to?
No, I'm happy with the lawyers' answer.
There's actually, on the music, there's actually some very specific legal precedents. And so when the World Cup was in Qatar, they had a little musical, a few bars of music at the beginning. And it was at the beginning, it was from an American song, I forget which one. So I sent it to a songwriter that I know and said, is this legal to copy? He said, well, it's 3 bars and the limit is 4 bars and something like that, that there actually were, there actually is specific, at least case law for what constitutes fair use. I think either the New York Times or Wall Street Journal had a story in the past week that's still in my file that discussed this in some more detail. And so it's a really, really important question because the degree, are you going to get a whole paragraph out of some article, or are you just going to get an association of 3 words? The 3 words is fine. The whole paragraph is not fine, but defining the line in between it is going to be really.
And there was a case with this musician that was in Game of Thrones. I mean, he played music, and people said he stole certain bars in his music, and he was sued, and he actually went to the trial and played his music, and the jury said, that's standard stuff. I forget his name. Do you remember what I'm?
That may have been discussed in this article. I've been so busy I haven't read it, but there are examples like this, and the World Cup one was really striking because it exactly like the opening bars of one of the Phil Spector was involved with. I forget
Yeah.
who actually sang the song, but it's a well-known song, and they
Yeah.
used the whole thing just without attribution, without. But they knew the law, and they knew they could get away with it.
Yeah.
You have about 5 minutes.
Yeah. Any questions or comments? I mean, we can keep going all day, which we're not, but
Can we question your underlying assumption?
you can question anything, but let the gentleman behind you, and then you can come back and question. Not only can you question the underlying assumptions, we would love if you question the underlying assumptions.
Thank you. One of the challenges, I think, for a lot of IT leaders and strategy leaders is as you include AI in your processes, especially when it comes from vendors outside of your own organization, as you turn decision-making into a bit of a black box. I'm curious if you have any predictions or thoughts on how doing some of this training data provenance work will help unpack the black box, or not at all, or what implications it has for.
Wow, that's a very interesting
I can say
question.
2 words and then pass it off.
Yeah.
I think transparency into models and data is a really big problem, especially from closed companies that don't want to open themselves to copyright litigation, so they're not transparent about what data they use. But it's essential for many businesses to know what was trained on for their own compliance reasons. I suspect that there's going to have to be differentiated models that are trained on fully transparent data in the future to provide for those businesses. But the community's fighting really hard for more transparency in all levels, especially if we think adoption of these models will be risky in some cases. So
Yeah, Mike, what have you seen?
Well, I think explainable AI is an area of active research, because even if you know all of the training data that went into a system, often you can't actually explain why did it make a decision one way or another. You can explain it mechanically, because I added up these weights in the neural net and it spit this thing out at the end. That's not the same as actually telling you the reason that a particular decision came out of the system.
And I think, is it fair to say, if it's a smaller open source model, at least people can do research to try to understand how the model is behaving. If it's a large proprietary model, it's like
definitely.
you're not allowed to do that. So those are interesting things. Now, you wanted to challenge.
Yeah, I wanted to ask a separate question though, which is, right now in cybersecurity, there's an issue of product liability finally coming to being an issue with product developers. For years, it was very hard to sue, to have a cause of action against developers of products who had a cybersecurity failure. How is that playing out, or to the extent do you think it is playing out in AI, where products are now giving answers that people might or might not have negative results from?
So from my perspective, the liability question continues to be really murky, in part because the harms that arise from kind of AI making mistakes are often not like cognizable under the law, right? It's these things about discrimination, which are sometimes really hard to measure, but we are seeing a rise in AI regulation, and not just in the EU. So there's the EU AI Act, which is interesting, but New York has a bill on discrimination in hiring with AI. Colorado has a bill on discrimination in life insurance.
The White House.
There's the executive order and on and on. So I think there are now ex-ante obligations. And to the earlier question, the question is who implements those? And oftentimes businesses will be in a really poor position to implement any of this because they're buying technology from vendors. And so what I expect is going to happen is there's going to be more kind of third-party auditing of the technology and ensuring compliance and some sort of compliance certification process, which is really nascent, but feels like it's a necessary component to this ecosystem in a world where you're buying technology.
So Michael, why don't you make your point about challenging our assumptions, which I liked a lot.
So the assumption, which is not unique to you guys, but it is that all we need is more data, as opposed to what we in areas where there is a right answer have a much better sense of. which is that there are wrong answers, and these systems produce wrong answers in situations where you know the answer is wrong, and the reasons as we see them, and we do similar analysis using different methods, but there's a lot of the things that we do that are just not present in the models, like the ability to take into account the frequency of a finding in a disease or something like that, or to take into account that you look harder for a disease that's treatable, or you're more wary of ordering a test that's expensive or takes a long time to come back. There's a lot of things that go into processes that have a right answer that are beyond just more data. So, I mean, there's various ways of dealing with this, with plug-in models or with...
We agree. I know we need to stop, but I don't think we're saying you need more data. We're saying you need to have the right data for the purpose that is legal and so on. I think, and what if there is a closing statement is, this is such a fascinating area of research, and both the kind of academic research you guys are doing and the kind of research in the marketplace that you are doing. And that's wonderful that it's such an open area of research. So I know there are people that say, no, we don't want research in AI. We want everybody to stop. The answer is, that is the most stupid thing I can imagine.
The ship sailed. That ship sailed.
Yeah, that ship has sailed. Thank you very much.